So my name is Lydia Doleman. Some of you I know very well, some of you I don't know. And I'm a natural building contractor who's been working in Oregon for over 25 years. And I specialize in what are called alternative wall systems, also known as natural building. So, um, any contractors, architects, engineers, city planners, firefighters? Yes. Anybody planning on remodeling their home the next foreseeable future yet, but at least you. Anybody planning on building new in the next 1 to 25 years? Okay. Perfect. So ideally, this presentation will both give you a sense of from a climate perspective, in addition to giving you a myriad of options where you could actually use your building project to help mitigate climate change. So, um, how about some other? There we go. Next one. Okay. So the arc of this presentation is we'll start out with a lot of text heady graph things. And if you didn't have your coffee today, I'm sorry. But then it will get maybe a little bit more interesting for those people who like the pictures and the how to. So just to make sure that we're all on the same page here, this is the only one that I will be story time where I read the entire thing too. But this is really important that we understand what the embodied carbon is. And I feel like these two quotes are really great. So embodied carbon is the sum of all the greenhouse gas emissions released during the life cycle of materials, including extraction, manufacturing, transport, construction, and disposal. And embodied carbon emissions for buildings account for 11% of the annual climate warming greenhouse gases. That's the GHG, if you didn't know, emissions globally. And so, why does this matter? I think everybody in this room has a sense of why it matters, but I will just reiterate what is in here, a few more highlights. That most of the building's lifetime greenhouse emissions occur before anyone occupies it. So it's more about what we are choosing to build our houses out of that have these significant impacts. And understanding the embodied carbon of building materials is crucial for designing and constructing buildings with materials that don't cancel out the climate gains made by operational efficiency improvements of recent decades, which we've gone leaps and bounds in terms of energy efficient appliances, lighting, windows, etc. Looking at your building is part of the climate solution through circular and efficient design, improved material manufacture and reuse, and policies that create market demand for low embodied carbon and carbon storing mix of concrete, steel, and insulation and other materials. So I'm going to focus heavily on insulation. And who knew insulation was so exciting? So we'll come to right button. I did. And this is the one, there's only one other depressing slide in here, but this is as depressing as my guarantee. For those of you who've been looking at the news. So buildings and carbon emissions, what we're looking at is construction accounts for roughly 40% of global emissions. This is a huge impact just for basically creating human habitat or a place for us to escape the habitat that makes us uncomfortable. And concrete and steel manufacturing are 12 to 18% of that. And that is because it takes an incredible amount of heat to manufacture those materials. And then with that, on top of that, the operation of these buildings account for another 20 to 35% of global emissions. This is the dark time, and this is what has created a huge chunk of our climate crisis. So here's another visual representation of that, just so that you can see it in chart form, and to really go over that the things that I'm really talking about will be the embodied carbon emissions plus the operational costs, which is the electricity that we use, heat, or the like. Yeah.
Is this more a modern day or is this going back several decades or centuries?
Modern day. So each of these is like they're doing this analysis somewhat on an annual basis. So that's 2019, that's 2021. And I don't have a lot of information from before we started to become conscious that like, let's calculate this. And all of this is with the caveat is somebody much smarter than myself has done all of this number crunching. I am a builder, but this is a part of what motivates me to build because I'm very motivated from an environmental perspective. So how many people here have heard natural building before? Can I get how many people are like, what is she talking about? Okay. So, and a common question that I get is what is the difference between green building and natural building? And there's a really important distinction here. So green building essentially is an umbrella phrase that captures building with energy efficiency and the environment with a heavy focus on energy efficiency. And we've all been told that green building is good, great. And yes, on certain levels, like, yeah, that's the direction I want to go. But natural building takes the premise of an energy efficiency and ecology, it takes it about 100 steps further. So, um, natural building or bio-based wall systems, that's a new term that seems to be emerging to describe natural wall systems, have these characteristics. And it's non-toxic, locally sourced, minimally processed, low tech, fire resilient, and then we will really talk a lot about carbon sequestering. And the bonus of it being non-toxic is that, you're talking about non-toxic in production and end use, and particularly for user or for since most of us are spending more than 50% of our lives inside the built environment. So there is something called sick building syndrome that some people do suffer from just from all of the off gassing of all of these highly processed um, petro-based materials that are in our houses. And locally sourced, of course, that's going to impact our environmental footprint, and same with minimally processed when we're looking at embodied carbon emissions. Now, the low tech aspect is something that I really love and appreciate because it also is this creative opportunity for incorporating people who aren't necessarily specialists in the building realm into the building realm. So, in some of these facets, because straw bale and other wall systems that I'm talking about, you don't necessarily have to be a carpenter who studied for 4 or 5, 10 years on how to do it, is that you can get friends and family and more people involved. So this makes this building system much more inclusive rather than our high-tech solutions. And of course, bioresiliency is an incredibly important topic here in the Pacific Northwest. And then there's carbon sequestering. So what I'm going to talk about is fiber. 'Cause fiber is key to longevity in so many different ways. And I'm going to go over these fiber-based wall systems that are all about drawing down carbon out of the atmosphere and storing it in wall systems. So straw bale, very popular. Hopefully everybody here has heard of it. And there's light straw clay. Not everybody's heard of it. And on that note, I'm going to pass this little bowl on around with, you can put your name on there, and then I'll do a little drawing and you can win a free book all about light straw clay. And then there's hempcrete, which is sort of new on the scene. A lot of people are very excited about it. And then there are these that for people who might be like, oh, that's a little too dippy or oomy groovy or just out of my wheelhouse, that these marry very well conventional construction. So dense packed cellulose has been around for a very long time and is carbon negative. And wool is somewhat of a new product that's available, as well as wood fiberboard. So with that, talking about straw, straw is the queen of carbon sequestration as it sequesters 60 times the carbon it takes to produce it, making it the lowest carbon footprint of any insulation material available at this time. So pretty amazing. The lily straw is the champion of insulation. And with that, just to reiterate this over and over again, is that the building sector consumes nearly half of the energy produced in the United States, and 75% of that is just essentially maintaining the temperature comfortable inside of those buildings. And with that, you can grow straw on 6 out of the 7 continents. So this solution is already here, present, with the exception of Antarctica. And in that, we are already growing 2 billion tons of straw annually a year for grain production. So how many people probably ate something with with a grain in it today? Most everybody here had that. So, and straw is essentially the waste product. And the miracle of this annual production of straw is that it is also sucking in, for every 2 billion tons of straw produced, 4 billion tons of carbon dioxide is being absorbed out of the atmosphere and into the plant that can then be stored in wall systems. And all of that is the equivalent to the emissions, more or less, of India. So if we were to bale all of that straw and stick it in buildings, we would be pulling out the equivalent of India's emissions each year. Uh-oh. Is it me or you clicking? Double clicking. There we go. Okay, there's also a vast array of bio-based or natural materials and waste stream materials that also check all of those boxes of being locally produced, non-toxic, minimally processed. They're also carbon sequestering, whether it's pinker products like the blown-in cellulose that I showed you, to textiles. There's denim insulation that can be used, to hemp-based products, bamboo, cork, which isn't global here, but in Europe, and then, of course, straw. And that essentially can translate buildings from being a climate bad guy, having a big negative impact, to being a climate hero. And that is through 3 simple strategies for mitigating climate change through construction. And the first one is renovating our existing building stock. So we have millions of homes in the United States, and particularly in the Pacific Northwest, when there have been cycles of construction, whether you're talking about buildings that were built in the late 1800s up into the 1940s, where they didn't do any insulation. So just upgrading that alone from an energy efficient standpoint, as well as a carbon sequestering standpoint, pretty awesome win-win situation, especially for the tenants or whoever the homeowner is having to pay those crazy energy bills that just keep going higher and higher each year. Now, the second one is, of course, to build a new structure with climate-friendly materials. But the third one that really could be pivoting us towards a carbon negative future would be to build with carbon negative materials. And that goes talking about straw. So again, just to have one more, there's three more graphs. Ray Whitaker's really tired. We're going to get through it. But this basically just really demonstrates operational costs, and it's essentially heating your building and heating your water. Everything else would make huge strides in energy efficiency when it comes to air conditioning, refrigeration, then lighting. But we still haven't figured out the best way, most efficient way to heat. So here is the graph that really pivoted me towards, I already was building with straw, but then this really began to resonate that we need to be building with a lot more straw and a lot quickly in order to mitigate climate change. And part of that was also it really shifted my perspective on what green building is. So a focus on energy efficiency, there are a lot of buildings because high density, medium density spray foams and polystyrenes, these things perform incredibly well from an energy perspective. They're incredibly insulative, but unfortunately, they have the highest emissions, just astronomical emissions when it comes from a carbon perspective. They're also very toxic when they burn. They're not recyclable. There's a lot of negative parts about it. But if you just look at the window that these are really great insulating materials, it checks that box. But it's kind of horrible in these other realms. So, did you end up? Or we, oh, yeah, yeah. And so the lower half of this graph is where you can see that this is carbon negative. So this is actually taking more carbon out of the atmosphere than all of those emissions for being processed and transported, and the heat beat treat model of industrial building materials. So straw bale, of course, they're the queen of all those materials. And you would have to build 3 straw bale houses to mitigate the environmental cost of one high density spray foam house, which is super unfortunate, but awesome that we have all of these options. And this graph really here, just no reading, unless you want to. But this is just to demonstrate here is that once you build your house, here are your carbon impacts on this orange part here. They're steady state. You built the house. This is the carbon emissions. But what grows over time are your operation emissions. So this is generally a 30-year timeline because that's considered the lifespan of the house in North America, which is tragically short and ironically the same length as most mortgages. Um, and you just see that it is increasing over time. So a combination of materials that are drawing carbon out of the atmosphere, storing them into the walls, and super high efficiency, we've got a potential win-win situation. So here, these numbers come from the Endeavor Center from a person named Chris Magwood, who has done a tremendous amount of development in terms of carbon research on natural wall systems. And now he works at the very prestigious Rocky Mountain Institute, crunching numbers for all us builder people. And he's from Canada. So these numbers are from Ontario, which is also a really good example because you have really cold winters. And since we're looking at energy efficiency and so much about being around heating, this is a typical home with natural gas heat. So you're going to have that big carbon input there. And so you can see it just a typically built home. And over the lifetime cost of 30 years, this is its net carbon emissions, those 84.28 tons of carbon. And I know these numbers are kind of heady and hard to wrap around, but and this is the high performance build with lots of foam, essentially. So once you add in those really carbon intensive foams that insulate really well, so like their operational costs have gone down, but their carbon emissions from the get-go are actually way worse than a conventional project. And in fact, their emissions are significantly higher at 118.8 tons over the course of 30 years. So this is the graph where when my friend was doing this, he was like, I had to have some else numbers because this was just too much for me to take in. That all of our attempts at being energy efficient in one direction have actually been going backwards from a climate perspective. And then to really compare these things this is a high performance natural build with straw, is that it starts out for the first 10 years of being completely carbon negative. And over this trajectory, as long as, you've done all your details and it's truly energy efficient, is your operational costs are really, really low. So this right here symbolizes like if we want to get out of our climate crisis or really start moving forward, we'll start incorporating these bio-based natural materials into our wall systems that we can have a really big impact. An impact to the point of if we switch all of our new buildings to that, is that we could take 38 coal-fired plants off. So the solution is like here, and we're just not really doing it, but we should because we've got schools of thought that we should be moving towards this, and ideally, if we want to be net zero by 2040, if we are incorporating these bio-based regional materials into our wall systems, is that we can actually do that. Um, so now we're moving on to how to do that. So with straw bale wall systems, there's a myriad of ways to incorporate a big chunky carbon mod, aka straw bale, into your wall system. And for the one little side note is that straw bale building is a truly American form of building. It was essentially developed in Nebraska when the baler got invented in the 1850s, and people had baled up some late season hay. And traditionally, people were building sod houses there because Nebraska is grasslands. It is not forested like Pacific Northwest. And in the era of efficiency, they just step their hay bales up and plopped a house on the top. And it's called Nebraska style. And they're houses that are still stood for over 100 years. And what they realize is like, oh my gosh, not only is it cool in the summer like the sod houses, but it's also warm in cold Nebraska winters. And so this kind of was latent for a while until in the 90s, the Sacramento Valley decided to ban and burn the straw because it's a huge rice straw production area. And farmers were trying to figure out a way to get rid of their straw because they couldn't burn it in the fields anymore. So then a group of really awesome creative people decided that, hey, let's just reinvigorate this idea of the Nebraska style building. And those are called load bearing, which you don't usually do here because we're in a seismic area. But really, it's just like a running bond, just like bricks of big fuzzy straw bales that wrap around the building. And you can wrap them around the interior. Just question.
How do you reduce fire risk?
Excellent question. I will get to that. And in fact, I will touch on fire with all of these wall systems. Um, yes, so here is if you had a conventional build where you just stack them horizontally and you notch them around the framing so that on the exterior, looks like a craftsman style bungalow. So there are a lot of different ways. That one's very stealthy, strong bill in there. And another system for mitigating a lot of the engineering costs or the in order for a conventional contractor to take on something that seems a little unusual and potentially risky, is that these are called bales on edge between studs. So the whole building is framed just as you would conventional building, and then straw is stuck on the inside and then covered with the plaster. And the nice thing about straw bales is that you get these big, deep, beautiful windows. There's a lot of wonderful aesthetic things that come from having these thick walled systems. And one little side note here is that we always try to make the most what we call passive solar design, which when applied to any building, whether it's conventionally built or not, is that you are essentially letting the sun come in the winter in order to passively heat your space and keep it out in summer when you want to keep it cool. And that is just free energy savings no matter what your wall system is. So it's just a really good example of that. And then in an attempt to scale up, this way of incorporating straw into buildings is canalized straw. So instead of people coming to your house and stacking straw bales in your wall, this is sort of like a manufactured home where in a factory, people are sticking straw bales into panels and then they get taken out on a truck, tilted up with a crane, and your wall system goes up in a day or two and you can put your truss package on. And this makes for a very clean build site and very quick, although sometimes you might miss the community aspect of raising all your straw bales. So fire resiliency, a key component. And part of that is all of our wall systems are up to fire code. And either whether you have the plywood with whatever exterior on the outside and usually some kind of plaster system on the interior. Now, fire resiliency for the bale itself is very hard to burn because the people in the room that room phone books, it's hard to burn a phone book because there's no oxygen in there and bales are baled very tightly. So they will just smolder. And in this instance is that these people have done all of their due diligence with very good defensible space, an excellent metal roof that's sealed off very well. And then they have nice overhangs that are ideally hardened off and a hardscape around here, not a lot of landscaping. And sometimes if your windows are recessed, then you have the ability to be very resilient in a fire situation. There are incidences where straw bale did not survive, but that's usually the way big members catch fire or it's just bad luck. Doesn't really matter how well you design your building. If you had windows and you have the big temperature differential, it'll break the window and the fire can reach into your house. Uh, so yeah, there's definitely concerns around the flammability, but straw is very actually hard to burn when it's in bale form. But I like to compare straw bale to this is sort of a comparison of conventional construction where we have lots of little pieces of wood held together by petroleum adhesives, and they're all very dry and very, very flammable, as we've seen along the West Coast over the last however many years, where we watched entire towns burn down under less than ideal circumstances. And then stepping back to that one slide where we talk about non-toxic materials in your buildings, it's like it's usually what you hear from firefighters is it's not the fire that kills you, it's the smoke that kills you. And that's because it is.
City of others like of trailer park rather than a
Yeah, this might be from the Alameda fire. I can't remember if it's from the Alameda or Lahaina. Yeah, unfortunately, we have a broad selection to choose from. So to lighten that note, we'll move to light straw clay. That was our last grim slide. So light straw clay has actually been around for centuries, and it's an old European building style. And what it is essentially it's straw mixed with a clay slip packed into walls. And so it developed as an evolution from what's called wattle and daub building, which was mud around sticks in between these old German timber frames here. And then they eventually realized that if they used straw in there, they got better insulation and it was lighter weight. Uh, and so it's a really modular system. It can be done on any sort of scale. And this is where you're just sort of essentially tossing a salad and then packing it into forms. So this is where we talk about low tech, inclusive, very fire resilient. And on the larger scale projects is we use big tumblers to do all of the mixing for us. And the thing that I really love about light straw clay is it's incredibly modular. So you see with the straw bales, say you're in a really tight urban environment and you don't want to sacrifice 15 to 24 inches of wall space on your precious square footage, is that you can build much thinner wall system with light straw clay and still meet energy code. And it comes, you can have a form system that will hold that loose straw mixed with the clay in there, whether it's a permanent formwork that would then get plastered over, temporary formwork that gets leapfrogged up and then it dries. And then you can end up with very beautiful carbon negative buildings that are all quite lovely. And of course, I'm going to show lots of things very incredibly fire resistant. So it's like each one of those its individual straws has been dipped in clay that would help stop the spread. It will only very barely smolder. Again, and trying to find research on evidence of these buildings burning are very, very difficult. So yeah, it's the wood that will burn your windows gray and everything inside is what burns. So the newest key on the block that people are very excited about is hempcrete. And hempcrete it's the hemp hurd. So it's it's a byproduct from fiber production and it's mixed with lime to cure in a wall system. So it's much like the like straw clay, except it goes through a chemical cure instead of drying process. And so the fiber gets taken off from the hemp for whatever products the fiber is going to go into. And this is essentially a waste product that gets chopped up and then you mix it up and it's kind of like a giant Rice Krispie treat and gets packed into your wall. And then it goes through a curing process and usually covered with some kind of plaster. And again, can be very, very beautiful wall systems and lends itself to all sorts of different shapes since you can do forms. And of course, again, very, very fire resilient once again, because there's just like now it's very dense and not a lot of flammable ability for open flame to form in there. So those are all the sort of like, if you're really out there wanting something exciting and different and new, but if you're like, okay, I have a remodel that I want to do, or I'm just looking for ways to incorporate carbon sequestering materials into my house, wool insulation is some option. Now, granted, this is all imported currently from New Zealand and has a low carbon footprint because it comes in on a ship, but we could start domestic production here in the United States if someone wants to start that company. Incredibly pleasant to work with. So here we are as ever worked with fiberglass. So not fun. But check out this guy. He's wearing shorts. Doesn't have a mask on. I worked with this stuff, and it really is like very, very lovely to work with. You can have blown in, you can have wool. It's coated with a borate, so it inhibits flame spread. And then there is dense packed cellulose that has been around for a very long time. And these two are becoming more price competitive because we're not really reading material anymore. We're getting all of our information online. So if this comes from recycled newspapers are closing and we're not reading printed material anymore. It's actually become more expensive, but it is also a great option for those of people who are not quite ready to go the straw or hemp route. And then there's wood fiber insulation that has been around. Europe is light years ahead of us, of course, which is great for covering something that's like a mass wall that's brick that might not be have any insulation. And it comes in these forms, very easy to cut, very easy to work with, and it is a waste stream material. So there are rumors of a plant from one of the companies on the East Coast coming out here to the Pacific Northwest, will be White City, which would be manufacturing these products coming out of, our sawmills that are here. So it would be a really great boon to the Pacific Northwest to be using what's essentially something that's just on the mill floor being turned into a carbon sequestering material. At this point, Washington State is about to adopt a new building code where if you have studs and the outside of your building is you're going to need to add a layer of insulation on the exterior of those studs. And what this is it's called mitigating thermal bridging. So if you've ever driven down your street on a frosty morning and you could kind of see each bay in someone's rafter, you could see a layer of frost and then a little tiny thin strip where the frost has melted all the way down the building. What that is called is thermal bridging. And it's because the wood members do not insulate to the degree at which your insulation in between those wood members insulates. And so they will be requiring that you wrap, for energy efficiency purposes, wrap your entire building in insulation. And a lot of people will probably go to the simplicity of foam, which unfortunately is 2 steps back from a climate perspective. So ideally, more wood fiber would be better. And then this guy's sweatshirt just kind of says it all: insulate better, live better, just basically this whole presentation. And you can also see it just marries really well with conventional construction. So ultimately, buildings can be the 6th biggest carbon sink in the world after oceans, forests, coastal environments, soil, rock, and fungi. If we were to completely transform our way of building, which is actually very doable because we have all of the information, all of the technology. It's very easy to switch gears. So ideally, we'd be switching that direction. I hope that gives you some hope. So I usually get some questions about mass timber as a form of carbon sequestering, which is basically incorporating more wood into your buildings, which we already have a lot of wood. And I'm of the opinion that forests do a great job sequestering carbon on their own. And if we would increase harvesting just to put it into our buildings, that we would probably do what humans are really good at, which is kind of going backwards. And then these are just some pre-picture slides. So these are all in Jackson County. So all of these forms of building are in the International Residential Building Code. They've all been approved by Jackson County jurisdictions, Josephine County. So this is straw bale and it's all very fire resilient design here too. These are eco nests, is that light straw claim wall system that is there. And they're developed by a couple called Robert and Paula Laporte in Ashland, and they have a very beautiful building style with timber frame. This is another very fire resilient. These are some architects, actually, this is in California, where their original straw bale house burned because they learned that you have to do some good detailing. And so this is their super survivor straw bale out in the woods there. And then this is just a good picture of the interior. So finishing these spaces, I usually stress to use a clay-based plaster, mostly because of the low embodied energy, the idea of getting that material locally. It adds a beautiful sculptural element to it. And clay has an amazing ability to regulate humidity in spaces, so making for much more comfortable air quality. And a couple big projects, there's Ocean Spray 4-plex straw bale in Ashland. So this is the first multiplex straw bale in Oregon. And it's 500 bales. I don't have the numbers on how much carbon is supposedly stored in this, but this was an amazing opportunity where we had a work party and brought in 50 people who came and helped stack all these bales and apply the blaster and made for a very, very beautiful building. And then there is this hemp project that is also in Ashland. That is the 2025 hemp project of the year. It's 4,000 square feet, and it is an absolute work of art with a 9-sided reciprocal roof timber frame. Just has all the amazing bells and whistles, and a 2-sided masonry wood here. And one thing about trying to figure out how to heat with wood in the future, wood masonry heaters are really efficient. It's 1 fire a day to heat 4,000 square feet, which, yeah, pretty amazing. And all of these lend themselves to like artistic opportunities, working together to whatever capacity that you want to, and also layers of connection. So of all of these buildings that I work in, people come in and they really want to interact with the walls. There's something like very attractive and alluring about them, whereas I don't think anybody was compelled to do that when they walked in this room. So, um, just saying, there's something a little bit special about it. And it doesn't have to be a small residential scale. There is a company in the Netherlands called Eco Cocoon that is doing this at a massive scale. So this is a 11 or 13-story building in Malmö, Sweden, all straw, carbon negative. This is a 40,000 square meter warehouse, also in the Netherlands, all straw. So these are ways of building bigger and not having the negative impact that we had in the past. And then more pictures for just context and beauty. And then this is a 1,000-year-old structure that's in Yemen, and it's 11 stories tall. So not only that, but that's a testament to the potential durability of these wall systems. So to conclude, so we have room for questions. This is the quote that I try to live by, and it's by David Graeber, who's a late and great, amazing thinker and writer. And it's that the ultimate hidden truth of the world is that it's something that we make and could just as easily make differently. And so that's what motivates me. And the other thing that motivates me is the concept of the butterfly effect. So for those of you who know the story around the history of the butterfly effect is trying to come up with a mathematical equation that can predict the weather because, if you believe in that very materialistic view of the world, that you might be able to math it. And then realizing that we live in this inherently interconnected system, that you can't separate one action from another, that's so profoundly connected that the subtle and presumably innocent fluttering of a butterfly's wings can cause a tornado 1,000 miles away. So ideally, this is a little butterfly, and we'll see what happens after this. And then I have a bunch of references if you want to nerd out and dig deeper about carbon or different building. And there's tons of videos and great people to look into. So if anybody has any questions, and then I can draw the little name out of the bowl and see who won a black. Okay, question.
Thank you for a fascinating presentation.
Okay.
There are two things you haven't mentioned. I'm curious about what your experience and take is on them. One is passive process, and the other is these houses that are made with 3D printers, and whether you can incorporate some of those materials as them.
Well, so far to talk on the 3D printer is most of them have to do a liquid substrate. So they generally tend to be more mass oriented. And mass is great for really hot climates and hot climates with predictable sun windows. So say like the Southwest has a history of adobe buildings that have been there for 1,000 years. And it works in that climate because adobe works, or mass works, like a battery. So if you get a hot sunny day, knowing that you're going to be followed by a cold night, that sun shines in, charges up a 12-inch thick wall system, and then it radiates out in during the night, creating temperature-stable interior without having to add insulation. And 3D printers could probably work in that situation. As a craftsperson, it's like being replaced by a Xerox machine. But in the times that we're in, to me, a multi-pronged approach. So there's some people that are like, oh, I don't like straw panels because they're not community building, but we need more straw in all of these buildings if we want to get to the point where we can actually start pivoting the ship in the direction that we need to go for some weather predictability in the future. And then for the passive homes, I think any building, regardless of what it's being built out of, if you're actively taking advantage of passive solar, you're doing the right thing, because it's just really, you're taking advantage of the free energy of the sun coming into your place. Did that answer your question?
Yeah. Yes, no. I was thinking more about in Germany, they developed this technique they call passive home, which has a countercurrent ventilation system where as air goes out, it transfers its heat, and they're very tight and highly insulated homes. Has that been something you've used in your building?
We try to make sure that we are meeting I'm totally drawing a blank on a word for the air tightness of your home, because anytime you have air leaks, particularly with air that might have a lot of moisture in it, is that you can create point loads if there's a dew point. And we have the luxury here where we have a very benign climate for building, but say you're in New England or Ontario, it is a not forgiving climate for building when it comes to point loads of vapor that are created, because we're steamy little creatures, and we cook pasta and take showers, and all of that moisture tends to want to go somewhere. So I have worked on projects that have heat recovery systems and things like that. And sometimes I have hesitation to end up relying so much on a mechanical system, because when the mechanical system fails, that's where I have hesitation, is like, how would we fix that? So for an exercise that I do with people is like, it's one thing to build a house for 30 years, which is what this model is based on, but it's a totally different thing to build a house for 500 years. And that begins to step away like, well, if we have a mechanical system, we're going to have to think about how to maintain that for the durability of multiple generations. And I think those systems are great and awesome if they function well. And then the question is, well, when they don't function well, how does that house work? And if it's a really, really tight house that relies on mechanical ventilation, you run the risk of it being unhealthy for the people to be in there. So not a bad thing, not a bad thing. So I'll leave it at that. Any more questions? Okay.
Yeah, what do roofs tend to be built with, or
Spruce. I mean, great question. If you're in the Pacific Northwest in a fire-prone area, always lean towards metal. That would be the route that I would go. And if you're in an area where you're not necessarily going to be impacted by fire to the degree at which we have a fire regime that goes through, or fire ecology, is then the sky is essentially the limit. And metal is great because you could capture water. It lasts a lot longer. It's recyclable. Those are the advantages of that. But then there's living roofs where you have plants that are growing on top of your building. I had a friend of mine who got tired of all what we're doing, was focusing on loft systems, when we do a natural roof, and she went and learned how to do thatch in England and became the thatcher. Not very applicable to the Pacific Northwest, but there are a lot of different ways to do roofs. Yeah.
Thatch roofs or thatch roofs, like it used to be a lot of old houses were thatch roof. Didn't they have to replace them once a year, or rebuild them once a year if they are straw thatch? Or
It would depend on which type of reed that they would use. So I can thank my friend Erin for teaching me all this stuff. And that mostly it would be the ridge cap would be the first to go. And so much like wood, it would come in and be this golden wooden, like wood has a beautiful color. And then eventually the sun starts to degrade it, where you notice how wood turns gray over time, and bust turn gray. It's too much sun exposure. And then they would replace the parts that needed to be replaced. But because it's all placed in these little bundles, kind of the way shingles used to be attached to the cedar shake roof, is you could take out individual bundles if they were an issue and pop the bundles in. But it's not really recommended, mostly because we don't really have the ecosystem to generate that much reed, and it wouldn't be appropriate here in the Pacific Northwest. But they are really beautiful.
so how resilient are they long term for water and for mold, or for anything in each of these, especially straw or
For the wall systems?
yeah.
Incredibly resilient, much like any building. If you design so that there's no water intrusion, you're going to be fine. So wood building, even exposed to water is life. And if you add water and heat, then you get mold. But for the most part, if you start out with dry bales, or your light straw clay dries out, or your hempcrete cures, or your fiberboard or whatever doesn't get ridiculously wet during the construction process and then sealed in, then your building is fine. And another thing to talk about is that for the top three, the straw bale, light straw clay, and hempcrete, is that we have a breathable wall system, what's called vapor oven. So there's a whole way that we've nerded out about building science and vapor permeability, but a vapor open system means that, you've sealed off everything so you're not having air go through, but vapor can transpire through your walls, so that if you were to get a small amount of water, like say leaking through a window, is that it won't get trapped in there. So it's like when you wear a Band-Aid in your hand, like that body part gets really creamy because it's just like it's trying to breathe out. These are wall systems that allow vapor to permeate through, but water to not intrude.
how flexible would it be to renovate one of these? It does seem okay. How flexible would these systems be to renovate over time as changes people need to expand or reduce, or just
Excellent question, because a lot of projects that I work on are now at the remodeling phase. So it has been very educational about what to do to plan for the future. Because most people will eventually change a bathroom and they will change a kitchen. So usually what I tell people is put all your electrical in conduit, because that's really the thing that you need access to and to move around. But for the most part, it's just like conventional construction where you can cut in and open up a wall and see how everything is after 15 to 20 to 30 years and then add on with the technology that you have at that point. And some people will add on whether it's they're using a new wall system that they're excited about or marrying it with conventional construction or sticking with the straw bale or light straw play. I haven't remodeled any Campcrete because it's relatively new. Yeah. But basically like it's the same as anything. So which remodeling can be a total pain in the butt. So just keep it. It's evil. Any more? And that question?
Yeah, it sounds very exciting. But I just have a question. And there's an abundance of the results available now, probably because not many people use it. But is there any danger that if everybody started using your natural resources, that there would become a shortage?
Ah, this is a great big systems question. So on some level, the way that we practice agriculture right now is not sustainable. So we are participating in an unsustainable system and using it to help support our unsustainable system to keep going. So really, truly regenerative farming would be tilling that straw back to the soil. But unfortunately, we live at a time where farmers don't do that anymore because they're trying to make as much money and replant as soon as possible and have to get the straw out of the field. So I just was a big conference where we were talking about this, where yes, it would be horrible if we were logging to grow straw to build houses out of. But that's entirely what could be happening if we maintain this like accelerated growth model. So the idea is that step one of mitigating is to renovate what we have. AMS, ideally there has been the trajectory in American architecture of bigger houses. Like we build houses for our cars. So having a house with a garage is like, it's silly that we have a house for our car and we're putting all of that resource into havens, but it's like, it's part of the American vernacular that you have a garage. So there would have to be a lot of shifts in how we approach things where we're making the most of the big picture. And it will be an interesting future when we get to that point where it's like, okay, we can't expand agriculture anymore to keep building these carbon negative houses because then it doesn't balance out. But I see what you're saying. It is a possibility. Yeah.
So, just a question for me. Have they started adopting some of these techniques in the modular home panels that are assembled on site? Is that something that they're starting to do?
Yes. So the straw panels are like that. So we don't currently we have a panel manufacturer that's doing a release party in the Bay Area sometime next month, which I'm very excited about. And there is a company in Vermont called New Frameworks that has been doing panelized straw for quite a while. And they have a seed program where they will train your company because what they believe in is horizontal growth. So instead of boning everything, it's about, we'll show you how to do this just so that we know that it's happening. And it creates like resiliency and redundancy in the manufacturing process. So there's some other companies do that. Hempcrete is also being panelized. I'm about to work potentially on a huge project where it's a 13 home project in Bend, where the panels of hempcrete will be manufactured in South Dakota and then shipped out to Bend. So that is happening, which I think from a scalable process, that's what needs to happen if we're going to address climate change at the rate at which we kind of need to.
Great. Thank you.
Well,
Yep. Yeah, ends everywhere. Okay.
If you ask, what would be your recommendation about floors?
Floors. It depends. Carpet is comfortable, but a lot of materials in carpet are not good for you. So wool carpeting would be the route to go, but it's very expensive. So then wood flooring, and you can find sustainably harvested wood flooring. And then another type of floor that I have done is an earth floor. So instead of using concrete or heavy chemical composites for your floor, it's basically earth with hardening oils on it. Or there's tile, there's reclay. There's a lot of ways to be innovative with stuff that's already in the waste stream to incorporate into your floor or materials that are already on site to do with your floor. Yeah.
So, question about decking material. I recently, in the process of replacing the decking material on a 30-year-old deck, and really couldn't figure out a carbon footprint of treated wood versus, say, cedar or redwood versus a composite. And end up going with a composite. Any thoughts on that?
That's a good question. I'm sure, I mean, it really kind of depends because you could be like, well, I'm going to do it out of teak, which will last forever, but teak doesn't grow here and could be harvested from an old growth rainforest somewhere. So, or you could get secondhand teak, which is a possibility. There's a company called Anthology Woodworks that specializes in kind of reclaimed lumber that comes from one location. They process it and send it out. Um, and then, if you harvested on your own site and made your own decking, and then if you were to look at treated lumber, then you really have to look at the embodied carbon of all of the stuff that goes in the chemicals, like what used to be like cadmium, arsenic, and chromium into pressure treated lumbers, and those are all mined somewhere else. And the interesting thing about materials is, unless they're raw like wood, things like computers or our clothes usually only represent 11% of the materials that begin to them, which is just this crazy statistic thing about even computers are even born to that. And it's a whole global economy that brings this like piece of magic into our world. And there is, I think it's called base, and you can look it up on the internet. And of course, this is something that Chris Magwood invented, and you can do a carbon calculation on there. So it'll take you, and I don't know how incredibly refined it is, like how nitty-gritty it'd be like, oh yeah, this was the Plymouth Falls versus I got it from the coast. If there's any way to like nitpick out that way, but it's a way of assessing embodied carbon in building products and can help you make decisions.
So what is it called?
Base, I think it's called BASE, which I forget all of the things. There might be BACE, carbon assessment. And Chris, you could look up Chris Magwood and then go down Maving
Chris
Magwood.
Maybe. Uh-huh.
Yeah.
Yeah. Brushing off the decking question, I'm curious if you have any thoughts. I know recycle companies like Ridwell use the plastics they're recycling to build decking material. I'm wondering if you know anything about the decking material that's being made from recycled food plastics.
I mean, they recycle, which is great. So you're using a waste product. Yeah, it depends on so the matrix of making decisions is like trying to be an ethical builder is like doing a constant calculus that's impossible of trying to figure out. And then digging deep, because we live in a global world, is very, very difficult. So if your objective is, I want the most ecological decking possible, then it's like, okay, these are the things that are meaningful for me. Recycled content is important. So then you look for somebody that has recycled content, or if it's label, or is it non-toxic, or it's for you to kind of assess the spectrum of what's better or worse from an ecological perspective, because on some level it's very subjective. And then you can kind of get it to whether it's just about carbon. And then that would be place-based as opposed to globally based, because then you're talking about the transportation footprint. So I don't know if that answered the question, just created more questions, but have fun with the questions. I wish I had all the answers that don't.
Where in Bint are you working on? I know that in Bint is like t-shirt weather, and then midnight is like about 28 degrees out if you're camping. And have you where is it in use in Bend, and is it in use with the big ones like what's it called, DR Horton, or the big companies? Could it be with the big builder companies?
Ideally, big companies will take on this. Ideally, they will. And I think sometimes for big companies, it's either they have to sell the image, or for them, it's about making money. So it's like there was a whole period of where the term greenwashing was around because they could sell you something because it made you feel good. But ideally, bigger companies will, it's like need certification, and there's all of these certifications for different buildings, which certain contracting companies will take on because it's like a showpiece flagship project that they can boast about, which is awesome because we want them to kind of do that. But this project hasn't happened yet. It's been designed. It's in the approval state with the city of Bend right now, and will happen in 2027, and it will be panelized. And it's an affordable housing project where it will be based on a condominium style where a particular entity owns the land, and then people can buy the houses, and it's a set rate of inflation or equity that people can earn, just because there is no affordable housing bend. It's like you think Ashland's bad, bend to see more big news. So that's the goal of that project, and hopefully it will happen. Sounds like it is.
So I've had the pleasure of building a bungalow. There was a community effort and it went really fast. It was amazing. That's why. My question is with Enfrey and the other things that use cement as their back. Have you ever worked with any pozzolanic materials?
I sure have. I love the puzzle. It means basically burnt clay, and it's a catalyst that makes cement more cement. And so we can nerd out about chemistry, but some people are looking tired. So, and with the hapcrete, some people do put a certain amount of cement in there, which acts as a pozzolan, which converts the cure time from an air cure to a hydraulic cure where it can harden underwater. Did I lose anybody? Because otherwise, if it was just regular line binding it together, the center of the wall would never cure because it doesn't have access to enough air. I mean, or it would take like a really, really long time for it to cure. So some people add a pozzolan, which makes it more concrete-like because the temperature to which you make lime from limestone is 900 degrees Celsius, and the temperature to which you make Portland cement from limestone is like almost 3,000 degrees. So there's way more embodied energy going into making Portland cement from limestone than it is from making lime, but there's still a tremendous amount of heat in that equation. But you get like Portland cement. Cement is kind of this miracle material, and it is the most prevalent material, man-made material, or the most used material second to water on the planet. So it's like you all drive cars, you walk those sidewalks, this whole building is made out of concrete. Every single one of your houses is on a foundation of concrete everywhere. Which is both a miracle, cool products, but also a climate nightmare because we're overusing it.
All right, perfect. Do your own one more round of bus stop.
With Martin? Marie, right? Martin Albert?
You win a book.
I can see them. Sorry, Tice Hero to come out. There you go. Okay.
Alrighty, thank you much, Lydia, for the presentation. We appreciate you. We got just a couple more minutes for some SoCan events. Deals, fast forwarding through my presentation.
It's all right. We'll let you out. I'll tell you when to go back and I'll go forward.
So next month up, we have Rusted Gate Farms from Central Point coming in to talk about sustainable agriculture. We're really excited to have them on. We've been trying to get Rusted Gate in for like 2.5 years after I met their development director. And then we both are just sometimes really bad at emailing, but we finally got them locked in for May. So we're excited about this presentation. Same time last Tuesday, next month. We want to offer a thank you for volunteers that came out and supported us on Earth Day. I think they had 10 to 12 volunteers. It was an absolutely beautiful day on the 18th at Science Works. And then we got to do a follow-up event at the Manor on the 22nd. So really great Earth Month we had here at SoCan. Follow us on the social medias, the likes, the subscribes, the shares. It makes the numbers go up, and it's always nice when some of the numbers go up. So we appreciate that. All of our events we found on the SoCan calendar on our website, socan.eco/events. And then a few partner events. Oh, no, still us. So the Federal Estate Program is currently gearing up to start our full-fledged planning for the candidate forum we'll be hosting that we do every other year. This one is September
29th for the state Senate and House races, and then October the 13th, both Tuesdays, for the County Commission and Congressional District 2 races.
Everybody should sort out 2 candidate forms. And if you are interested in helping us coordinate those candidate forms this year, you can reach out to Alan at alan@socan.eco, or there's a link on our calendar for the next meeting, which is happening on May 11th via Zoom at 2:30. We have Sustained Climate Activists. What actually 2 o'clock? 2 o'clock. Appreciate you, Alan. We have Sustained Climate Activists, one of our longest running programs at this point, I think. The next one will be, I put April, that should be May 23rd. Sustained Climate Activists is an amazing group of individuals who recognize that climate change
And the climate crisis is a marathon, not a race. And it's easy to get burnt out and feel really frustrated. So we had a couple of facilitators come in with experience with listening circles and community gatherings to give a space for people to just be happy or be sad or be frustrated or be all of the things that we are because we're human. And that one. And then community partner events. So KS Wild every month for First Friday in Ashland does a First Friday Bonanza. Last month, they partnered with Rope to Go, and they were doing screen printings. This month on May 1st, they're partnering with Friends of the Cascade Siskiyou National Monument. They always have wine or refreshments if you find yourself in Ashland. And next up from the Southern Oregon Land Conservancy, they are now in full swing for their events. If you've never gone on a guided hike with SOLC, they're an amazing group, and we appreciate them being partners. And then also check out the Rogue Valley Voice. Rick Vanetti, out longtime SoCat supporter, manages his own kind of eco calendar of events. So if you're ever curious and looking for things to do in the Valley, he puts that up every month. And finally, I just want to appreciate you all for being here, spending this lovely spring day with us, and we will see you next month for Western Bay Farms. Thank you much.